Deinocheirus, pronounced Deinocheirus from Greek meaning terrible hand, is a genus of large ornithomimosaurian theropod dinosaur from the family Deinocheiridae, which lived in what is now southern Mongolia during the late Cretaceous period, in the Nemet Formation, about 70 million years ago. Initially, it was believed to be a large member of the Dromaeosauridae family, but this hypothesis was dismissed after more parts of its skeleton were discovered. The first fossils of Deinocheirus were found by Polish paleontologist Zofia Kielan-Jaworowska on July 9, 1965, at the Altan Ula 3 site, coordinates 43 degrees 33.987 north, 100 degrees 28.959 east, in the Nemek Basin, Gobi Desert. Zofia was part of a Polish team that, along with Mongolian paleontologist Rinchen Barsbold, took part in the Polish-Mongolian paleontological expeditions from 1963 to 1965, organized by the Polish Academy of Sciences and the Mongolian Academy of Sciences. Between July 9th and 11th, the team excavated and transported the specimen they found. A report from 1968, authored by Kielan-Jaworowska and Naiden Dovchin, highlighted that the fossils belonged to a new family of theropod dinosaurs. The specimen was discovered in a small sandstone hill and consists of a partial and disarticulated skeleton. Most of the bones had already been eroded before the discovery, leaving behind the 2 forelimbs, except the claws of the right hand, the complete shoulder girdle, parts of 3 dorsal vertebrae, 5 ribs, gastralia, abdominal ribs, and 2 serrata branchials. The specimen was designated as the holotype of Deinocheirus Mirificus, named by Halska Osmalska and Ewa Ronevich in 1970. The genus name derives from the Greek deinos, meaning terrible, and chair, care, meaning hand due to the size and strength of the forelimb claws. The specific name, Mirificus, comes from Latin and means uncommon or peculiar, chosen for the unusual structure of the arms. The Polish-Mongolian expeditions were notable for being led by women, some of the first to name new dinosaur species. The original number of the holotype was ZPAL MGD-I/6 but was later recatalogued as MPCD 100/18. The forelimbs and shoulder girdles of this holotype are currently on temporary display at Kosmokaisha. The limited number of known Deinocheirus fossils made it difficult to fully understand the animal for nearly 50 years, leading the scientific literature to often describe it as one of the most enigmatic, mysterious, and bizarre dinosaurs. The arms of the holotype became part of a traveling fossil exhibit from Mongolia, touring various countries. In 2012, Phil R. Bell, Philip J. Curry, and Yongnam Lee announced the discovery of new fragments of the holotype, including parts of gastralia, found by a Korean-Mongolian team that rediscovered the original quarry in 2008. Bite marks on 2 gastralia were attributed to Tarbosaurus, which may explain the fragmented state of the holotype. In 2013, the discovery of 2 new Deinocheirus specimens was announced during the annual Society of Vertebrate Paleontology (SVP) conference by Lee, Barsbold, Curry, and other researchers. These 2 specimens lacking skulls were catalogued as MPCD 100/127 and MPCD 100/128 and are under the care of the Mongolian Academy of Sciences. The specimen MPCD 100/128, a subadult, was discovered at the Altan Ula 4 locality during the Korean-Mongolian Dinosaur International Expedition in 2006, but had already been damaged by fossil hunters. The second specimen, MPCD 100/127, was discovered at Bugin-Sav in 2009. This specimen, slightly larger than the holotype, was identified as Deinocheirus due to the left forelimb, which helped associate the previous fossil with the same species. This specimen was also looted by collectors who removed the skull, hands, and feet, leaving only a toe bone behind. It is believed to have been stolen after 2002, based on money found at the quarry. Fossil hunters often target skulls, claws, and teeth, which are more valuable on the market, while the rest of the skeletons are vandalized. In an interview, Curry mentioned that it was his team's practice to investigate looted quarries to try to recover anything of value, and that any new Deinocheirus fossil was a cause for celebration. even if important parts were missing. At the SVP conference, the presentation of a virtual model of Deinocheirus received applause from attending paleontologists, and American paleontologist Stephen L. Broussat stated that he had never been so surprised by a presentation at SVP, although new fossils are regularly shown at these events. Following the announcement of the new specimens, rumors emerged that a looted skull had arrived at a museum in Europe via the black market. The stolen elements were seen in a private European collection by French fossil dealer François Escuyer, who informed Belgian paleontologist Pascal Godefroy about them in 2011. Both suspected that the remains belonged to Deinocheirus and contacted the Korean Mongolian team. Escuyer subsequently acquired the fossils and donated them to the Royal Belgian Institute of Natural Sciences. The recovered material included a skull, a left hand and feet, which had been collected in Mongolia, sold to a Japanese buyer, and resold to a German group. The fossils also passed through China and France. The team concluded that these elements belonged to the specimen MPC-D 100/127, as the remaining toe bone fit perfectly with the still unprepared matrix of an illegally hunted foot, with both the bone and the matrix showing the same color. Additionally, the elements belonged to an individual of the same size, with no overlap of skeletal parts. On May 1st, 2014, the fossils were repatriated to Mongolia by a Belgian museum delegation in a ceremony held at the Mongolian Academy of Sciences. The assembled skeleton was placed in the Central Museum of Dinosaurs of Mongolia in Ulaanbaatar, alongside a Tarbosaurus skeleton that had also been recovered after being stolen. American paleontologist Thomas R. Holtz stated in an interview that the new Deinocheirus remains looked like the result of a secret love affair between a hadrosaur and Gallimimus. A cast of the MPC-D 100/127 skull, the first known skull of this genus, was displayed at the Munich Fossil Show. Combined with the recovered elements, both new specimens represent almost the entire Deinocheirus skeleton, as MPC-D 100/127 includes all material except the middle dorsal vertebrae, most of the caudal vertebrae, and the right forelimb. MPC-D 100/128 fills most of the gaps in the other skeleton, containing almost all of the dorsal and caudal vertebrae, the ilium, part of the ischium, and most of the left hind limb. In 2014, the specimens were described by Lee, Barsbold, Curry, Yoshitsugu Kobayashi, Hangjae Lee, Godefroy, Escuyer, and Sogtbatar Chinzorig. A similar series of events was reported in early 2014 with Spinosaurus, another theropod with a sail-shaped back, which until then was only known from a few remains since 1912. Illegally hunted fossils were combined with specimens obtained by scientists, and Spinosaurus turned out to be quite different from other spinosaurids. These two cases demonstrated that the lifestyle and appearance of extinct animals, of which few remains are known, cannot always be safely inferred from close relatives. In 2017, the Mongolian government intensified its efforts to recover looted fossils from collectors and repatriate them, but proving their origin became both a scientific and political issue. Thus, a study tested the possibility of identifying illegally hunted fossils using geochemical methods, with Deinocheirus and other dinosaurs from the Nemegt Formation as examples. In 2018, several large tridactyl dinosaur tracks, three-toed, were reported from the Nemegt locality, discovered in 2007 alongside sauropod tracks. Although these tracks resembled hadrosaur tracks, no hand tracks of these dinosaurs were found, and since it is now known that Deinocheirus feet were similar to hadrosaur feet, it cannot be ruled out that these tracks belong to this species. The best preserved parts of Deinocheirus are its forelimbs, which measured 2 meters and 40 centimeters in length, with the humerus measuring 938 millimeters, the ulna 688 millimeters, and the hand 770 millimeters, including recurved claws up to 19.6 centimeters long. Each scapulocoracoid of the shoulder girdle had a length of 153 centimeters. The neck was likely also enormous, as each half of the paired ceratobranchials measured 42 centimeters. The colossal size of these skeletal elements led to much speculation about the animal's total dimensions. Osmalska and Ronovich suggested that it could be compared to Ornithomimosauria, as the structure of its arms resembled the limbs of that group. If Deinocheirus were part of this group, it would be by far the largest Ornithomimosauria, and in fact, one of the largest theropods. The scientists who initially described it estimated its size to be similar to the largest specimens of Tyrannosaurus. The two described specimens were the adult IgM 100/127 and the subadult IgM 100/128. Based on collected data and using Scott Hartman's skeleton as a reference, it was estimated that the holotype would have reached a height between 11.5 and 11.8 meters, with a weight ranging between 7,000 and 8,000 kilograms. However, the specimen IgM 100/127, the described adult, would have been even larger, as it had a femur measuring 1.32 meters, being 4% larger than the holotype, reaching a length of 12.3 meters and an estimated weight between 7,400 and 8,400 kilograms, making it the largest specimen. Additionally, there is a specimen from the ZPAL collection, based on a 72-centimeter ulna, that could proportionally be 7% larger, reaching a length of 13.20 meters and weighing between 8,000 and 9,000 kilograms. But more data are needed to confirm this with 100% certainty. Undoubtedly, it is one of the most peculiar, extravagant, and gigantic theropods ever described. In 1988, Gregory S. Paul estimated its weight between 6 and 12 tons. Subsequent studies confirmed that the animal weighed about 9,000 kilograms. In 2010, Paul revised his estimate to a length of 10 meters and a weight of approximately 2 tons. Also in 2010, Phil Center and H.J. Robbins attempted to calculate the total height of Deinocheirus at the hip region. After studying better documented theropods, they discovered that the length of the scapula, or shoulder blade, was a better indicator than the humerus, arm bone, for predicting hip height. Using an equation based on a variety of theropods, Center and Robbins concluded that Deinocheirus likely stood between 3 meters and 30 centimeters and 3 meters and 60 centimeters at the hip. This would make it possibly the tallest theropod ever known, surpassing contemporary predators such as Tarbosaurus. Although Deinocheirus's arms were extremely long, being the longest among all known theropods, they were not particularly long relative to its shoulder girdle, with a proportion smaller than most ornithomimosaurs. The scapula was long and narrow, while the humerus was relatively thin. Both the radius and ulna were elongated but were not rigidly connected by a syndesmosis. The metacarpus was long compared to the fingers, and the hand had good mobility relative to the forearm, though with limited flexion movement, unable to close to grasp. The fingers were nearly the same length, with the first being the most robust and the second the longest. Only the claw of the left second finger was fully preserved, with a diameter of 196 millimeters and a length, along its outer curvature, of 323 millimeters. The diet of Deinocheirus is still uncertain, but based on its classification and the discovery of fish scales and plants in its stomach, it is believed to have been omnivorous. Despite this, it is not considered an active predator. Deinocheirus likely fed on insects, small dinosaurs, other smaller animals, and fish. Additionally, its mouth appeared adapted for consuming plants and small animals, and may have also occasionally fed on fungi. The taxonomic classification of Deinocheirus was challenging when only its forelimbs were known, leading to various hypotheses. Initially, Osmalska and Ronovich concluded that Deinocheirus did not belong to any previously described theropod family, leading them to create a new monotypic family, Deinocheiridae, which they placed within the infraorder Carnosauria. This classification was based on the large size and robust bones of the animal, though they also noted some similarities with Ornithomimus, and to a lesser extent, Allosaurus. In 1971, John Ostrom was the first to suggest that Deinocheirus belonged to the group Ornithomimosauria, while also acknowledging certain features that were and were not typical of this group. By 1976, Rinch and Barsbold named the order Deinocheirosauria, which included the genera Deinocheirus and Therizinosaurus, considering them related. Some scientists supported a relationship between Deinocheirus and the Therizinosaurs due to their long arms, but this connection is now largely rejected, despite their superficially similar appearance. However, many depictions in paleoart still portray Deinocheirus with therizainosaurid traits, often causing confusion. In 2004, Peter Makovicky, Kobayashi, and Curry suggested that Deinocheirus was likely a primitive ornithomimosaur, lacking some of the typical characteristics of the Ornithomimidae family. Primitive traits included its curved claws, low humerus to scapula ratio, and the absence of a syndesmosis. A 2006 study by Kobayashi and Barsbold suggested that Deinocheirus could be the most primitive ornithomimosaur, though its relationships remained unclear due to the lack of cranial and hind limb elements. A cladistic analysis in 2014, after the discovery of two much more complete specimens, revealed that Deinocheirus formed a clade with Garudimimus and Beishenlong, leading to these genera being included in the family Deinocheiridae. The short, blunt claws of Deinocheirus resembled those of the therizinosaur Alxosaurus, suggesting that its long arms and claws were used for digging and collecting plants. The blunt claws on its feet might have helped the animal avoid sinking into soft ground while walking through water. Its robust hind limbs and pelvic structure indicate that the animal moved slowly. The large size of Deinocheirus likely provided protection against predators like Tarbosaurus, but as a trade-off, it lost the ability to run like other ornithomimosaurs. The long neural spines and possible fan-shaped tail may have been used for display. Deinocheirus was likely diurnal, as its relatively small sclerotic rings suggest. Its hands had good mobility relative to the forearms but could only flex to a limited degree, lacking the ability to grasp. The brain of Deinocheirus was reconstructed using CT scans and presented at the 2014 Society of Vertebrate Paleontology Conference. It was globular, similar to that of birds and troodontids, with a characteristic theropod expansion and relatively large olfactory tracts. However, the brain was small and compact relative to its body, with a reptilian encephalization quotient estimated at 0.69, considered low for theropods and more comparable to sauropods. Unlike other ornithomimosaurs, which had relatively large brains, the small brain of Deinocheirus may be related to its social behavior or diet. Coordination and balance were likely less critical for Deinocheirus than for carnivorous theropods. In 2015, Akinobu Watanabe and colleagues found that, like Archaeornithomimus and Gallimimus, Deinocheirus had the most pneumatized skeleton among ornithomimosaurs. Pneumatization is advantageous for flight in modern birds, but its function in non-avian dinosaurs remains uncertain. It is suggested that this trait might have helped reduce the mass of large bones, potentially related to the gigantic size of Deinocheirus, high metabolism, balance during locomotion, or even thermoregulation. The Deinocheirus, a large peculiar theropod dinosaur, has intrigued paleontologists for decades due to its unusual features and mysterious lifestyle. Recent studies on its bone microstructure suggest that this dinosaur likely had a high metabolic rate and grew rapidly before reaching sexual maturity. A histological analysis of a gastralia fragment from the holotype specimen revealed internal structures similar to the ossified tendons seen in other theropods, with the presence of canaliculi in the osteons marking a first in primitive ornithomimosaurs. The absence of growth arrest lines in the periosteum suggests that the holotype was a fully developed adult. Interestingly, bite marks found on gastralia fragments attributed to the giant ornithomimosaur Deinocheirus Mirificus suggest interactions with the theropod Tarbosaurus batar. These bite marks, with parallel striations and serration marks in a U-shape, align closely with the teeth of theropods from the Nemет Formation, indicating that Tarbosaurus likely preyed on or scavenged Deinocheirus. This discovery provides new insights into the diet of Tarbosaurus and the taphonomy of Deinocheirus fossils. The peculiar skull shape of Deinocheirus, featuring a duck-like beak, hints at a specialized diet compared to other ornithomimosaurs. The small attachment sites for jaw muscles suggest a weak bite, indicating that Deinocheirus likely fed on aquatic vegetation or soft understory plants. The depth of the lower jaw implies the presence of a large tongue, which may have helped the animal suck in food while foraging in shallow waters. A handclaw mold revealed a rhomboid and recurved shape, and over 1,400 gastroliths, stomach stones, were found among the ribs and gastralia of specimen MPC-D 100/127, supporting the idea that these stones aided in grinding food in toothless dinosaurs. The combination of a beak and U-shaped, downward-facing jaw suggests facultative herbivory among these theropods. However, vertebrae and fish scales found among the gastroliths indicate that Deinocheirus was omnivorous, feeding on both plants and small animals. In 2019, researchers David J. Button and Zano found that herbivorous dinosaurs primarily followed two distinct feeding strategies: gut processing, characterized by delicate skulls and weak bite forces, and mouth processing, associated with greater chewing capacity. Deinocheirus, along with ornithomimosaurs, diplodocoid sauropods, Titanosaurs, Segnosaurus, and Caenagnathids, fell into the former category. These researchers suggested that Deinocheirus and ornithomimosaurs like Gallimimus occupied these niches independently, achieving relatively large sizes through convergent evolution. The benefits of large body mass in herbivores include increased food intake and resistance to fasting, suggesting that Deinocheirus and other ornithomimosaurs were likely more herbivorous than other ornithomimosaurs. However, the diet of most ornithomimosaurs remains poorly understood, and Deinocheirus appears to have been, at least occasionally, omnivorous. Before more complete Deinocheirus remains were discovered, several hypotheses were proposed about its feeding behavior. Initially, it was imagined as a predator similar to an allosaur with giant arms. In the original description, Osmolska and Ronevich concluded that the hands of Deinocheirus were not suited for grasping but could be used to tear prey. In 1970, Russian paleontologist Anatoly Konstantinovich Rojdestvensky compared Deinocheirus's forelimbs to those of sloths, suggesting it was a climbing dinosaur that fed on plants and animals found in trees. In 1988, Gregory S. Paul suggested that its claws were too blunt for hunting, but would serve as effective defensive weapons. In 2010, Phil Center and James H. Robbins proposed that Deinocheirus had the greatest vertical feeding range due to its hip height, making it specialized in consuming high foliage. In 2017, it was suggested that the claws of Deinocheirus were adapted for pulling large quantities of herbaceous plants from water, reducing water resistance during movement. The three known specimens of Deinocheirus were found in the Nemegt Formation in the Gobi Desert of southern Mongolia. Although this geological formation has never been radiometrically dated, the fossil fauna suggests it formed during the early Maastrichtian stage of the late Cretaceous, around 70 million years ago. The rock layers of the Nemegt Formation indicate the presence of stream and river channels, mudflats, and shallow lakes, suggesting a much wetter climate than the older Barungoyo and Jadokta formations, although caliche deposits show that dry periods also occurred. Sediment was deposited in large river channels and floodplains. Deinocheirus likely had a wide distribution within the Nemegt Formation, as the three known specimens were found 50 kilometers apart. The river systems of this formation created a suitable habitat for Deinocheirus, with its omnivorous feeding habits. This environment was similar to the modern Okavango Delta in Botswana, where Deinocheirus likely fed on plants and small animals like fish. It may have competed for trees with other large herbivorous dinosaurs, such as the long-necked theropod Therizinosaurus, several titanosaur sauropods, and the smaller hadrosaurid Saurolophus. Deinocheirus may have competed for tree foliage with these herbivores, but it also had the ability to feed on material they could not access. Along with Deinocheirus, the discoveries of Therizinosaurus and Gigantoraptor show that three groups of herbivorous theropods, ornithomimosaurs, Therizinosaurs, and oviraptorosaurs, independently reached their maximum sizes at the end of the Cretaceous in Asia. The ecosystems around the rivers of the Nemegt Formation, where Deinocheirus lived, supported a wide variety of organisms. Occasional fossils of mollusks have been found, along with a range of other aquatic animals such as fish and turtles, and the crocodilomorph Chamosuchus. Mammal fossils are rare in this formation, but many birds have been discovered, including the Enantiornithine gurilinea, the Hesperornithiform judenornis, and Teviornis, which was possibly an anseriform. Herbivorous dinosaurs of the Nemegt Formation include ankylosaurids like Tarchia, the Pachycephalosaur Prenocephaly, large hadrosaurids like Saurolophus and Barsboldia, and sauropods like Deinocheirus and Opisthocoelicodia. Predatory theropods that coexisted with Deinocheirus include tyrannosaurids like Tarbosaurus, Alioramus, and Bagiratan, as well as troodontids like Borogovia, Tocosaurus, and Zanabazar. Omnivorous and herbivorous theropods include therizinosaurs like Therizinosaurus, oviraptorosaurs like Elmosaurus, Nemegtomia, and Rinchania, and other ornithomimosaurs like Ansaramimus and Gallimimus. Over the decades, our perception of Deinocheirus has undergone an impressive transformation. From a feared predator to a large omnivore, its true nature was slowly revealed, layer by layer, in the rocks of the Nemegt Formation. The ongoing study of these fossils has not only expanded our understanding of Deinocheirus, but also of the complexity and diversity of the ecosystems it once inhabited. And while many answers have been found, each new discovery brings new questions. After all, that's what makes the study of dinosaurs so fascinating. The feeling that no matter how much we learn, there will always be more mysteries hidden, waiting to be uncovered.